summary of the laws of indices across all the sections. 1. A to the power x times a to the power y is equal to a to the power x plus y. Number 2. B to the power x is equal to a to the power x times b to the power x. Number 3. B to the power x times cb to the power y is equal to ac, then times b all to the power x plus y. Number 4. A to the power x then all to the power y is equal to a raised to the power xy. Number 5. A to the power x divided by a to the power y is equal to a raised to the power x minus y. Number 6 is a raised to the power 0 is equal to 1. Number 7 is a to the power 1 is equal to a. Number 8, b to the power x divided by b to the power y is equal to a over b times b all to the power minus x minus y. Number 9 says a over b all to the power x is equal to a to the power x over b to the power x. Number 10 says a to the power minus x is equal to 1 over a to the power x. The 11th law says a raised to the power 1 over n is equal to the nth root of a. The 12th law states a raised to the power m over n is equal to the nth root of a all to the power m. In applying these laws to carry out number operations in indices, there is one caution you must take. Please take the caution. And that's the caution. It says more than one law could be required to evaluate a number operation. What it means is that if you want to carry out a number operation and you now discover that what you need is a lot of indices, don't insist that one law will be required or will be used to evaluate it. Many times, yes, I mean it, many times, the number operations in indices which we face contain more than one law. That is to say, it requires more than one law in being evaluated. So be very careful that you don't insist on using just one law to tackle a particular number operation in indices. What then are the tips for using the laws of indices in carrying out number operations involving numbers in the index forms? Let's find out. Here come the tips, about 4 of them. They can also be called the steps of using the laws of indices to evaluate numbers and number operations involving numbers in index forms. The first one says, determine which powers govern which numbers. I believe you understand what this statement is pointing at. All right. Number 2, determine how many laws required. Sometimes one law is required, sometimes 2 are required, sometimes 3 are required. Just determine how many are required for evaluating a particular number operation involving laws of indices. Number 3 says, determine which law should be applied first, then next. Yes, sometimes we have to find out which law should be applied first. Sometimes there is no law about the order, but sometimes we have a law as to which one should come first. Whatever there is a law or a kind of caution to be taken as to which law should be applied first, please determine which of the laws is to apply first and then next. The 4th one, apply the law or the laws accordingly. And this is example number 1. 1 over 3 raised to the power minus 3. Which laws do you think are going to apply if we want to carry out this number operation or to modify this expression? Check if you're going to agree with me. In the following laws, which I believe are applicable in simplifying this operation? Please check. Principally, these two laws will apply. This law and this law will apply. First, let me apply this law. And that gives us 1 over 3 raised to the power 3. This is the much this law can do for us. What is next? We are going to apply this law to simplify this base. Now watch as I apply this law in simplifying this further. Here it comes. It is equal to this 1. It is still what is here, over 1 to the power 3, see it here. 3 to the power 3, see it here. I hope you can see how I applied this law. Next, 1 is still here, see it. This is equal to, that is brought from here. 1 to the power 3 is 1. I hope you know why 1 to the power 3 is equal to 1. Recall that 1 to the power 3 does not mean 1 times 3. Instead, it means 1 times 1 times 1, and that is equal to 1. Then over, see it here, 3 to the power 3 is equal to 27. So the whole of this has become this. Is this the last answer? No, certainly. What happens next? I think at this point we are done with these two laws. What applies next is outside the laws of indices. Let's continue. This is the same thing as saying this 1, see it here, divided by, see divided by 1 over 27, 1 over 27. The next is that we're going to use the law of dividing fractions to simplify this. Let's apply it. Before we apply it, let us rewrite this in this form so that it has, this one has a structure of fraction. And this is it. Next, we apply the formula for division of fractions to simplify this expression. What happens next? Please watch out. And that is it. This is 27 over 1. I hope you know why this became this. Let me remind you of the law I applied in simplifying this to make it become this. Please watch. That is it. A over B divided by C over D is equal to AD. That is A times D over B, C. That is B times C. See it here. Our A in this context is this 1. Our B is the 1. Our C is 1. Our D is 27. So our AD is 1 times 27, and that will give us this over. Then our BC is 1 times 1, and that will give us this 1. So when 1 divides 27, the result is equal to 27. And that's example 1. What about this example? This is 2a all to the power minus 1 times 3a to the power 2. We have to realize at this point that this minus 1 governs both 2 and a, and this 2 governs only a. Now, what do we do? Which laws are needed for simplifying this? First, let us realize that more than one law is required, and in fact, we can solve it in more than one way. Each law applied at each level of solving this problem reveals a method of solving it. Let us start with outlining the laws that will be required to simplify this or for solving this number operation. And here come some or all of the laws that we will need in simplifying this, and we have them here. In carrying out this number operation, some or all of these laws are going to be needed. Let me apply some or all of them in simplifying this. Please watch what happens next. And this is what happens next. Which of these laws do you think was applied here? Certainly, I applied this law here so that this became this, and this remains the same thing. I hope that is clear. Next, I have to apply this law to associate this 2 to the power minus 1 with 3. This is where they are associated. See clearly that this law is what I applied here. What then happens next? It is simplification. Let's simplify where it is necessary and possible and check what it turns out to be. See what happens next? This 2 to the power minus 1, based on this law, has become 1 over 2 to the power 1, which is 1 over 2. Then times this 3, see it here. Then times is still here. A raised to the power, please, minus 1 plus 2 is equal to 1. So this line has become this. I hope what happened here is clear to you. What happens next? We are supposed to get one figure from this bracket. Currently we have 1 over 2 and 3. The two of them should multiply to give us just one figure. What is it going to be? And afterwards, we unite that comes out of this bracket with this a to the power 1, which eventually is equal to a. Let's see. Certainly, 1 over 2 times 3 has become 3 over 2. I hope you know why. If you don't know, go back to principles of fractions. And then a to the power 1 is the same thing as a. That reminds me of the fourth law we have to apply. This is a to the power 1 is equal to a. That means that so far we have applied this law, this law, this law, and this law in carrying out this number operation on indices using laws of indices. All right, at this point, please, again, what happens next? Simplifying further, 3 over 2 times a will give us what? Let's see. See it here. 3 over 2 times this a is the same thing as 3 over 2 times, which is still here. To make it easy to multiply these two, let a take the structure of a fraction. How do we do it? We just place 1 under 8 so that it takes the structure of this 1. 3 over 2 times a over 1, so that we apply a lot of multiplying fractions, which is this times this over this times this. Okay, 3 times a is 3a, 2 times 1 is 2. So the answer to this number operation in the simpler form is equal to 3a over 2. We can make this long process shorter. Let me use relatively shorter process. In solving this using the shorter process, I want to apply this straight away to the entire 2a raised to the power minus 1. Let me do it. And that is it. This has become this. This sign is still where it is. Then this is 3a to the power 2. 3a to the power 2. So what happens next? Let me rewrite this 3a to the power 2 to take the structure of this 1, which is like a fraction, so that we can apply the formula for multiplying fractions to get the answer. See it here. This expression is the same thing as this. The importance of this line is just that this 1 is introduced so that this 3a to the power 2 takes the structure of a fraction like the first one, so that we apply the formula for multiplying fractions. That will be this times this over this times this. Here we go. 1 times 3a to the power 2 is 3a to the power 2. then 2a times 1 is equal to 2a. So the whole thing becomes 3a to the power 2 over 2a. If you simplify it further, what you get is the same thing we got earlier, 3a over 2. Which of these two approaches is easier and shorter? Obviously, this one is shorter, but that does not mean that you are under restriction as to which of these laws you're going to apply. The long process, the short process, whichever one you want to apply that is mathematically acceptable, use it as long as the answer is sure. This example says x to the power 0 times x to the power minus 1 times x to the power 5. What do we do? We are going to apply a law or a group of laws. Which laws are applicable here? These laws are applicable, this first law and this one. Let me apply this in simplifying this operation. And here we go. Recall that this law is valid whether we have only two numbers in index form or we have three or more. As long as this is applicable, it is also applicable if we have more than two numbers in their index forms and the same base multiplying themselves. This is not said out of sheer carelessness. It was tested to be true. Therefore, if you want to be sure that what I'm saying is correct, please get numbers in their index forms having the same base and more than two in number. Use constants to a kind of carry out the test. Multiply them using a method that is traditional and come back later to solve the same problem or to carry out a number operation using laws of indices. You discover that the answers are going to get are the same. Therefore, this law is applicable to more than two numbers in index forms and in the same base. Then, that is therefore applicable to x to the power 0 times x to the power minus 1 times x to the power 5. That being the case, they all have the same base x. That is how we picked just one base x, then add the powers. This is 0 plus minus 1 plus this 5 here. And that gives us this x to the power minus 1 plus 5. Whenever we add 0 to anything, the result is that thing. That means that there is nothing this 0 is doing here. It is not changing the value of this power. So it is only minus 1 and plus 5 that are going to determine the final power of the last answer. Minus 1 plus 5, what is it going to be? It is going to be 4. Therefore, x to the power minus 1 plus 5 is equal to x to the power 4. And that is the answer. Is it possible to apply a different approach in simplifying this? Surely it is. Let me use a different method. And let me, before I do that, remind you of another law we can apply in simplifying it. Let me use a new set of laws of indices in carrying out this number operation. Here we go. I apply this law to ensure that this x to the power 0 becomes 1. I apply this law to ensure that this x to the power minus 1 becomes 1 over x to the power 1. Then, next, we multiply by x to the power 5. This is how this line of action came to be. What is next? I intend to use the law of multiplying fractions to simplify this line of action to give rise to the next line of action. That takes us to this 1 given as 1 over 1 times, the times is still there, 1 over x to the power 1, x to the power 1 is still x, then this sign is still here, then x to the power 5 is x to the power 5 over 1. Next, we apply the law of multiplying fractions in simplifying them. What is it going to be? it is going to be this times this over this times this. 1 times 1 times x to the power 5, what will it be? And then 1 times x times 1, what will it be? See it. Yes, 1 times x to the power 5 is equal to x to the power 5. And 1 times x times 1 is equal to x. So if you simplify this with any known correct mathematical operation, including a lot of indices, you will arrive at the same answer, x to the power 4. Don't forget that when I solved this earlier, the same answer is what we got. So whichever way you go about it, as long as your actions are not wrong mathematically, you are sure to arrive at the same answer. Look at this question. It says 7 raised to the power x minus 1 times 7 raised to the power 1 minus x. Notice that the power of 7 is not x alone, neither is it minus 1 alone. The whole of this is the power to 7, and the whole of this is the power to this 7. So what set of laws are we going to need to simplify this? Let's find out. This alone will serve. Let's apply it in simplifying this number operation. And so don't forget that this alone is the power of this 7, and this is the power of this 7, and this is multiplication, just like this. So in the end, we're going to add the powers. That means we're going to add this to this. See where I'm adding them together. That will be 7 as a common base to power this x minus 1 plus. That is the plus here. And then 1 minus x, see it here. If you open these brackets with 1 each, beside each bracket, you're going to see that the result is 7 raised to the power x minus 1 plus 1 minus x. I hope you know how this became this. Let's make progress. If we just oppose like terms, we have it as 7 raised to the power this x, bring it to itself, and then this becomes x minus x. Don't forget that when this minus x is going to join this plus x, the sign will not change because it is not crossing a sign of equality. And so we have it as this x minus this x to have it here. The next is this minus 1, see it here, and then plus 1, see it here too. X minus x is 0. Minus 1 plus 1 is 0. That means that in the end, the whole thing is equal to 7 raised to the power 0. Is that the end? No. What next? Let's see. And that is it. The answer is equal to 1. It therefore means that the whole of this expression, when evaluated, is equal to 1.